Hello, friends. We are back with episode 153 of the Our Weekly Highlights podcast. This is the weekly show where we talk about the latest happenings and the tremendous resources that you can find every single week at the ourweekly.org website. My name is Eric Nance, and I'm delighted that you join us from wherever you are around the world. We're about past the halfway point in February, so spring is coming soon, I hope. But I can't do the show alone, of course. I am joined by my awesome co-host, Mike Thomas. Mike, how are you doing this morning?
I'm doing well, Eric. Yeah, I think probably the audience can hear in our voices that spring isn't quite here yet, but we're getting there.
Yeah, combo of the cold weather, kids bringing you-know-what home from their respective daycares or schools. It never ends. It never ends. But nonetheless, we're going to power on through here. We got a lot of exciting content to share with you all today. And this content for this particular issue was curated by Tony Elhabar, who had tremendous help as always from our fellow Our team members and members like you, contributors like all of you around the world with your awesome pull requests and suggestions for more excellent resources. As I said, Mike, we do sense spring is coming, and that's where I know my kids like to start getting their bikes out to take the bikes rides around the neighborhood and whatnot. Well, it's appropriate that as the weather's warming up, our first highlight today is taking a very data-driven approach to just how far you can take your bikes and analyze that for some real fun exploratory data analysis and the like. And this post comes to us from Greg Dubrow, who is a data analyst who is now based in Denmark, and he has a very passionate hobby, so to speak, of riding his bike basically everywhere he can go. He's been doing this from wherever he's been in the world. His first part of the blog post gives a nice background on the various bikes he's had growing up, even a little mishap he had last year during that, which any bike enthusiast can probably relate to. But nonetheless, he talks about, taking advantage of recording his bike riding data using an app called Strava. I've not heard of this before, but apparently it gives you a boatload of metrics having to do with your bike riding. And the first question comes, okay, well, you got this data on the app, right? How do you get it out of that? Well, you could download a bundle from your profile on the Strava site as one way to get a CSV text dump of that, which he does end up doing. But like anything else, there is an API for that, right? And not only that, there is an R package to help you grab this data from R itself called R Strava, which he utilizes, as well as, like I said, the aforementioned CSV data dump, if you will, and merges that together to give them a nice, tidy data set after some, very usual cleaning and reshaping and manipulation of dates and whatnot, so that it's actually ready for analysis. So again, an awesome data-driven approach to take advantage of modern tech to put this data into R itself. You've got the data, now what? Like a lot of the posts we cover in our weekly, we start with some fun exploratory data analysis. And to get things going quickly, he makes use of a very cool package that I've actually seen utilized with some of my colleagues at the day job, as well as others in the community, called Data Explore. This is a really nice package that gives you a very quick way to explore, say, the missingness in your data, as well as doing some very nice correlation heat maps right off the bat with your numeric variables. And he senses that, most of these variables have a positive correlation to the key metrics such as distance and the actual moving time of the bike, where this app is apparently smart enough to detect when the bike is actually moving versus stationary. So really novel use of tech here. But the post has both the variables and their percent of missing values, as well as this aforementioned heat map with the correlations to help begin informing just what kind of relationships he will explore later on in the post. And you start to sense some of the things you might think intuitively, such as the average speed of his bike being positively correlated with distance, albeit not as a huge relationship right off the bat. And also some correlations with the power output of the ride and measured in average wattage usage may have some negative correlations with other metrics and the like. And then augmenting these visuals from the correlation perspective is the tried and true scatter plot, which he uses a very novel functional approach that he got inspiration from one of Cedric Scher's posts that he does all things ggplot too, and with a little bit of magic with patchwork, able to get these nice correlation plots for the key response variables of distance, moving time, and average speed. And you again start to see positive correlations amongst many of the key metrics, such as calories, average watts, moving time, and etc., to give him a better idea of what he might expect out of a more rigorous analysis. And just where does this rigorous analysis take place? Well, we all like some tables, right? So he starts off with creating some fun GT tables of just the metrics in terms of the total time, elevation, total calories outputted throughout the year. And you can see out of 446 rides, he's burned a lot of calories and generated a lot of energy. Lots of cool summaries there. And then we got some more visuals, Mike, where he looks at the seasonal pattern of his ride shares per month. So why don't you take us through some of the visuals you're seeing here?
Yeah, it's a really nice visual blog post. I think Greg notes that he leveraged some of the tutorials that Cedric Scher has put together. And if you are in the data viz space, especially in the R data viz space, that is a name that you are certainly familiar with. One of the visuals that I thought was pretty cool that he used was most rides during, it's showing the number of rides that he has and the type sort of in this polar area coordinate diagram. And the reason that he did that is to correlate them to the hour of the day that it took place. So it's this chart is sort of representing a clock, which is a really cool, I think, use case of these polar area coordinate diagram type charts. I struggle to find a lot of use cases for those charts in a lot of my EDA analysis and data viz work, but I think this is a perfect use case for it. So I really appreciated that. Going back to talking about some of the dependent variables that he used, one of the dependent variables that Greg used was called kilojoules, I believe. Hopefully I'm pronouncing that somewhat correctly. And he used that variable instead of calories because according to Garmin frequently asked questions, calories expended are the total energy in the time that it took to do the workout that you expended, while kilojoules is the energy actually burned by the workout, and that formula is watts times seconds times 1,000. So that was very interesting to me, and I know a lot of workout apps there sort of focus on calories, and maybe they should be focusing on kilojoules instead. So I thought that was pretty interesting, some of these GT tables and the way that he was able to format them in the blog post to have a lot of these GT tables actually side by side instead of one on top of the other using some HTML was a pretty cool, nifty trick to make this blog post sort of nice and neatly put together as well. So a lot of really interesting work here, and then he actually fits some models at the end of this here. There's a time model, a kilojoules model, and then a watts model as well. And the model fits all look pretty good. I'm pretty impressed, and it's sort of a function, I think, of just the amount of data that this Strava app allows you to have control over and to take a look at. And you can do some pretty cool, as Greg shows us here, some pretty cool analysis with your workout and exercise data, particularly with your cycling data in the Strava app. So a really cool use case, I think, walking through a lot of different types of data visualization, some predictive modeling, sort of an end-to-end data science project here using a pretty nifty data set. So hats off to Greg for a great start to our weekly highlights this week.
Yeah, really awesome approaches here, and looking at even the source of his Quartal document that this blog post is based on, you're going to see, like Mike, you said, those nifty tricks of putting the tables and some of the plots side by side. Really nice, easily viewable post here. We got the table of contents on the right margin. Yeah, lots of ways to hop back and forth amongst this. So again, Quartal gives you a lot of these niceties out of the box. And really hats off to, owning your data as best you can, albeit, a third-party app is collecting it, but fair play to Strava for giving an API for users to expose this. Because there are some others out there in the fitness tracking space that aren't quite as friendly about you getting your exercise and workout metrics out of it. So really, really encouraging to see, for all you cyclists listening out there, and I'm a part-time cyclist when I can, that's really cool to see you be able to take advantage of this amount of data, and Gray's got to be a pretty fit person to be able to have this amount of rides in 2023, even with the injury that he underwent early in the year. Like, that is impressive stuff, impressive dedication, and maybe I need to not be so lazy this year. We'll see.
And hats off to Greg as well, and Cordo, for the nice collapsed code chunks that allow you to see exactly how he did what he did in this blog post.
Yeah, isn't that a great, UX, so to speak, of digesting the parts you like, and then maybe you're more interested in, say, the modeling part, or more interested in the visualization part, or, of course, interested in everything, but you can opt into looking at all those details and still get the full cohesive story here. So, really enjoyed the post. Looks like he spent a lot of time drafting this together, but again, it's all available for us to see in the open, and I'm going to have to maybe get a new bike this year so I can start tracking some metrics.
Me too.
Now, maybe, Mike, you're on a long bike ride. It may seem like every time you think you've got to your destination, there's some little hurdle along the way, right? And maybe it's a traffic light. Maybe it's, who knows what else is happening out there. Sometimes package development can feel like you're so close, you get that glimmer of hope, and then something really crazy happens. That's where our next highlight comes in, coming us from our fine friends at Think R. This has been authored by Swan Fulackley. I probably didn't pronounce that at all correct, but apologies in advance. But they have an excellent blog post here about how you can tame the namespace of your R package and making use of the suggest call of it. So, like any good story, this starts with what seems to be a smooth road. The example package in this post is a simple wrapper on top of ggplot2 to help export the plot with a simple function they call save plot. It looks innocent enough, right? We are simply letting the user specify, after they specify the ggplot object, the extension, which can be one or more of like PNG, JPEG, or PDF, where to put it, what's the file name. Pretty straightforward stuff. It's just wrapping a call to ggsave with a little bit of per on top of that. And the usage looks very straightforward. The example looks very logical. You're going to plot your data set, use the save underscore plot, clean up after yourself. Well-constructed example. So like anything in package development, you're going to start checking this on your local system using DevTools : check most of the time. Comes through, flying colors. No issues at all. No errors, no warnings, no notes. You are feeling good about it. And like in good practice, this package code is on version control with GitHub. So why not just rely on your local system to do the checking? We like to use GitHub Actions now to do a lot of this automated checking as well. And that's where things start to go a little off the rails, because we are now embodying the infamous slogan in CS and development. It works fine on my machine, but on the CI check, we see a cryptic error. And where does this rely? Well, you go down the rabbit hole checking the logs. In the details, there's an error saying that there was an error running the example code, which again, the example looks straightforward. Worked fine locally, right? Go down that backtrace a bit further, and then you see this error about load namespace. There is no package called SVG Lite. Oh boy, what on earth happened here? Now we got to put our detective hat on. Where in the world is SVG Lite being used, Mike? What gives?
Well, it's going to be in, and you would only see this in the source code potentially, or the package description file. But it's going to be in the it's a dependency of ggplot specific to the ggsave function. When you are saving a plot using the ggsave function from ggplot2 as an SVG, it's going to employ the SVG Lite package. And one of the reasons why you don't have this in your CI/CD check is because SVG Lite is not a hard dependency of ggplot2. SVG Lite is in the suggests portion of the dependencies of ggplot2. So it is not going to get installed automatically when you specify that ggplot2 is a dependency of your package. So, this is a very familiar probably territory for those of us who have done a lot of our package development and ran into similar situations like this before, either, wrestling with whether a dependency should be a hard import or should be in the suggests section of your description file, how to manage dependencies that are only specific to maybe vignettes or things like that. So this is very familiar territory to me. I have maybe a story that I might tell if we have a little bit of time here, but I think it sort of just goes to the overall narrative here that sometimes things may work well on your machine, but when you start to employ CI/CD that is going to leverage a different machine to build and test that package, you may see a failure there. And honestly, that's a good thing. Because what that means is that when someone else on a completely different machine than yours wants to use your package, and that's the whole idea, to build software that is useful for other folks as well, they might run into the same issue. Even though you saw no issues, warnings, errors, or notes in your own DevTools check run, it's a good thing, in my opinion, that when you send it off to GitHub Actions in this case, that this error presented itself and pops up, and let you know sort of exactly what the issue was. I think the error message is pretty descriptive, and obviously you do have to do a little bit of detective work to figure out, hey, where the heck is SVG Lite even impacting us in this particular case? But if you've been around the block a little bit with ggplot2 and you sort of understand what you're trying to do here in terms of saving that plot, hopefully it won't take you too long to figure that out, as it did in the case of Swan. So, I think this blog post also nicely calls out the use of the Fusen package, not Fusen, it's the Fusen package, which for those who are unfamiliar is a package that streamlines the development of our packages. And I believe it sort of uses an R Markdown approach, a chunks approach to sort of execute different commands through a nice documentation framework and sort of build out all of the different components that you need for that R package. So, I don't know, Eric, if you want to take over sort of more of the final solution here to ensure that this package passed all of its CI/CD checks when it went to GitHub Actions.
Oh, yeah, I'm chomping at the bit for this because, boy, do I feel seen on some of the ways this can be implemented. So now that we realize that SVG Lite is definitely required for this save plot function, there are a couple options or how this could be tackled here. One is that in the roxygen preamble for this function, we declare an import from SVG Lite, the SVG Lite function. That is certainly a valid approach, right? Well, when you run a check again, even locally, you're going to see something appear that may seem really scary, and frankly, it can be, where you will be warned about, hey, you know what? Now the imports of your package may seem small, may only seem like it needs ggplot2 and SVG Lite, but that is now ballooned to 21 non-default packages that are now going to be required at install time to get your package installed. Now, the CRAN maintainers put this check in our command check. This note I'm about to say is that importing from so many packages make the package vulnerable to any of them becoming unavailable. Yes, we have covered in years of this podcast when one dependency suddenly got quote-unquote archived on CRAN In fact, they even affected ggplot2, I believe, and amongst others. So how appropriate here. So, but you still need this package, or do you need it? Now, this is where suggest comes in terms of now taking this preamble out of the roxygen, putting svglite in the suggest field, and then in your function having a check via the require namespace function to check if that user has installed it or not on their local system, and to prompt them to install it in order to get the full support of all those file types that are being exported. But it would still import, in the case of the solution here, it will still import the file types, or export, I should say, the file types that don't need SVGLite. So there's a happy medium in here from a UX experience to what they politely say, avoid the backlash of what can happen from both you as a developer, but also as the end user to know what to do next. So it may seem like a little more upfront work, but the good news is that now the dependency footprint of your package going to CRAN has become much less, such that now the user, or in your CI/CD for running the examples, can opt into installing this package without having the hard dependency on it, and hence minimizing the potential for the dreaded archival status on CRAN if any of these dependencies end up going away. So there is another nugget here, though, is that when you install a package from, say, GitHub, like they have a nice snippet on here using the remotes ::install GitHub, name of the package, repository, by default, it will not install dependencies that are marked as suggest. That's where you have to supply the dependencies flag of true in order for your local system as an end user to grab, in this case, that SVG-like dependency. That's a nuance that has tripped me up so much in my day-to-day work. When I thought I'd install a package from GitHub, I'm ready to throw it in my Shiny app or throw it in my other pipeline, and then I realize, oh, what's that error? Oh, nope, didn't get that suggest package when I installed it. So that's at the end of the post, but it's bitten me up many times.
And that's contrary to the base R install.packages function, right? Which will install by default the packages that are listed in the suggest portion of the description file.
That is correct. There's a dichotomy there that unless you really stumble into it, you don't really know exists. So that was some shared learning for me. So yeah, I'm curious, Mike, to hear your tale, if you will, of this issue. For me, I have two minds on this. If I'm developing a package that's just for internal use at my day job, admittedly, I'm probably just going to put it in imports anyway, because at that point, I know I'm not going to CRAN. It's more about, does this pipeline I'm making, is the benefit of throwing this onto, say, a Shiny app hosted on Posit Connect or other areas, what's the easiest way for me to control what's happening there? And that's typically, if I have a description file, just throw it all in imports. But if in a situation of either a CI/CD or CRAN itself, yeah, I definitely would take this advice to heart, because it will make your life as a maintainer easier, not to worry about in this case, SVGLite's tangled web of dependencies, when all you need it is for one additional type of file to export in this case. It is not going to impact the baseline functionality of said package. It's just an enhancement on top of it. I admit sometimes it's hard to find that good threshold of when you go to import only or when you go to suggest only. I think that comes through experience, but for me, it also depends on what context you're going to be releasing this package in.
Yeah, I would agree. I think I'll default here and punt a little bit and say that the R packages book, which is authored by Hadley Wickham and maybe Jenny Bryan and a few others, don't quote me on that, I think has some really good discussion about when to list a package as a hard dependency versus a soft dependency, and also how to handle, packages that are just being used. This is something that we run into a lot, packages that are just being used in a vignette, and ggplot2 is one for me that happens quite a bit with, because maybe I don't have any functions within my package itself that leverage ggplot2. We're just returning data, but in my vignette I want to show how this package can be useful to users. So I want to build a beautiful chart, and have that be on our package down site, and folks come and see that and look at that and be like, wow, this is what I can do with this package, but not necessarily auto plot anything for them, because I have plenty of opinions on why I don't necessarily like functions that do that. We just try to return the data and let you use ggplot2, use eCharts for R, do whatever you want, GT, to make it beautiful. But I guess one other thing that I will add as an anecdote here that Swan mentions, which I think is really good advice, is when you are managing the dependencies, within your particular package, highly recommend using the use package function, which will handle not only where things should be listed within that description file, making sure you don't have anything duplicated in there, but also it will handle the relationship between that description file and your namespace file, and any updates that need to be taken on that namespace file, which should not be done by hand, which is highly recommended. So I would recommend leveraging that package. Just another example where use this can be awesome. I'll try to keep this brief, but we developed an open source package recently that actually downloads some publicly available data that's stored as a zip file on a website. And when it downloads, onto my machine or onto any of our company resources, local machines, any of my teammates' machines, the data comes in, and it's a strange data set in the zip file of these text files where say there's 4 data sets, for example. There would be 8 text files total. The first 4 would be the column headers, and then the next 4 would be the actual data itself without column headers. So you just have to stitch them together, and file 1 is the headers for the data in file 5. File 2 goes with file 6, file 3 with 7, and 4 with 8. You can match them up. They're ordered that way when you download them online. So we never had any issues locally with essentially, returning a data frame that matches the headers to the data itself, until we tried to use the with R package in our unit testing to do this programmatically deployed to GitHub Actions CI/CD. And when we ran these tests locally, everything worked totally fine, because we just said you match file 1 with file 5 and 2 with 6, and so on and so forth. When the with R package ran on this Linux box, probably on GitHub Actions, the files that got unzipped from the zip folder got unzipped in strange orders, not the order that they were stored in. So just got totally reordered, and it was very difficult to figure out what the issue was that was going on here. And so we just had to write in a little extra logic that uses the naming conventions of the file names to match them together, which wasn't a big deal at all. But we couldn't rely on the order that those files came in, because for whatever reason, when this ran on GitHub Actions and unzipped these files, they unzipped in a totally different order than what took place locally for us. So, just an example of how you can pass all of your checks locally, but not necessarily when you are running it in a separate environment, which was a good thing. I was glad that we ran into that issue, so that if for some reason, somebody leveraging our package experienced the same issue where the files unzipped in a different order, our functions would still work.
Yeah, boy, is that just par for the course when you expect the unexpected, so to speak, when you put in things in CI/CD. I had a similar thing, albeit it was more me shooting myself a bit in the foot on this, but I was doing a pipeline in GitHub Action. It's not an R package, but it's a set of functions that grabs a SQLite database from online, does some transposing, does some massaging, does some fuzzy duplicate finding, and then sends it back out as S3 objects. Well, in my development, I was starting to do like date cleaning with the Lubridate package. I had installed it locally. I forgot to add it to my manifest for the GitHub Action to install it. And I've actually was leveraging friend of the show, Peter Soimus's deps package to make a JSON file of the dependencies. I just forgot to rerun that darn thing and then commit it. So I'm like, wait, it worked fine on my machine. And I was like, well, dependencies again. So it happens even in non-packaged context. So you just gotta keep devoted to keeping that stuff up to date, whether it's an RM block file, a deps.json, or whatever else. It just keep that stuff up to date, man.
It's hard. There's a lot to it, but in my opinion, it's super important because we want the user experience of others, using the software that we create to be as high quality as possible.
That's all the name of the game, isn't it? Yep. But really entertaining read here and very informative too. So credit to ThinkR for sharing their knowledge of the developments in the trenches, so to speak. And Mike, yeah, those are two pretty heavy, content highlights here, and we're gonna have some fun with this next one because I like me a little game now and then. So our next highlight is gonna do a little fun classification magic to hopefully help you win this game even faster than you might expect. And this is coming to us from Michael Holle, professor in statistics and data science at the University of Greifswald, Germany. Again, pronunciation is not my strong suit here. But he starts introducing this blog post about a game that he likes to play called Guess My Name, where each player will have a card with 16 kind of avatars on them. They each have different, hair color, maybe slightly shirt, different genders, all that. And the object of the game is each player will pick who they want to represent on this game, but then the opponent has to ask questions to help narrow down who that opponent would actually be on the board itself. And they can only ask questions about the picture of the person, and the response to that must be either yes or no. So you can kind of start crossing off who is not, and then figuring out eventually who that person actually is. So, of course, naturally, the winner of the game is going to be one that finds the answer in the least amount of questions. And so Michael, what he does in the first part of his post is actually compiles a spreadsheet of about 12 questions that you will logically ask in this game amongst then the players that these questions would represent. So you can download that spreadsheet right off the blog post if you want to look at that for reference. He's got a snippet of it in the post itself, such as do they have headgear? Do they have glasses, blonde hair, et cetera, et cetera. Now, that's a great starting point, right? But where do you help determine what should you ask first in order to maximize your chance of winning? It's decisions, right? Well, literally here, because we're going to look at decision trees as a way to help take a data-driven approach to find this solution. This is not something I would have expected, but it's a pretty clever use of the classical classification tree method, where he feeds in the data. In this case, like I said, that spreadsheet of questions and then the membership of each person responding yes or no to those questions, throws it in an R part call after it does some massaging of the data, and then the rest of the blog post now gives you a decision tree that you can use as a strategy going forward for how you might identify these players. So, if before seeing this post, Mike, would you have guessed that the first question that someone should ask is whether the player has blonde hair?
I wouldn't have guessed that, but it has been a little bit of time since I last played a game like this. I think there's a game very, very similar. Maybe it's more US based, and I think it's called Guess Who. Played it a lot when I was growing up, and you flip the people up and down after you ask questions, and it's kind of like a 20 questions game to see who can figure it out first. So this sounds like exactly the same thing. And if I remember correctly, I think that was one of my top questions. Does the player have blonde hair? And trying to narrow down who the person is that you're trying to get at. But I guess it all depends on your strategy and the data or the people that you have on your card.
That's right. And so when you look at this decision tree further, once you get through that initial question, then we start branching off into questions like, is the picture have something green in it? or something red. So you're looking at color next across the entire picture. Now, the type of gear they're wearing. Is there some headgear? Is there a short sleeve or a long sleeve shirt visible? Hey, can we see the eyebrows under glasses? Like, it is a very interesting dichotomy here of where you should go next. But it just shows you another clever use of classification methods, which again are typically the backbone of almost all types of machine learning, especially in the dichotomous approach, where you're trying to optimize that response or predicting a response. These are the fundamental building blocks. Obviously, if you're in a more rigorous analysis, you might look at other methods and classifications, such as random forest, GBM, and the like. But if you ever want a gentle introduction to what classification trees are actually doing, with a little, perhaps, ways you can use this in your activity time later on the weekends, this you could do a lot worse than seeing what Michael's post has here.
No, this is a super cool, super fun application. I guess not something that I've seen too often in the highlights before. We've seen some exercise data, before, but in terms of actually like playing a game, I think this is super cool and a great use case, and I think a great learning case for leveraging decision trees and the RPart package itself. Sometimes I think algorithms can be explained best on like small data sets where you can see sort of exactly the decisions that are being made by the algorithm or how the math really plays out. Just as another final story for the week, I do have somebody in my family, I'm not going to name names, but when we play Clue, they essentially need a laptop with Excel open next to them to be able to sort of track everybody's responses in a spreadsheet, just way over the top analytics approach. And to be honest, they actually are the person that usually wins, which makes me feel like I need to do something during that game. But I'm off the clock, so to speak, when I'm playing board games. So I try not to go. Try not to pull out all the stops, but if this person does keep winning, I may have to spin up R in something like this and come back to Michael's post, because I think a decision tree type of approach is not only applicable to this particular game that we're looking at here, but Clue is another one that comes up for me that would be a fantastic use case and application for leveraging something like a decision tree, because it's a question-based game as well, where you're trying to sort of narrow things down into the smallest number of pieces of information that sort of give you the best idea of what the true answer is at the end of the day. So that's the end of story time for me for this week.
It does make me think, albeit it probably have to use even more rigorous methods for this, but as a kid, I loved playing that game Battleship and trying to figure out which space should I target first, and then based on that, knowing that it didn't hit, how far away should I go from my next target? I could sense there'd be a lot of fun data-driven approaches to that. But for those of you listening, if you're interested in more of the technical math behind this idea, well, the blog post has a terrific appendix here where you can really, really get to school, so to speak, on how classification methodology works here. Michael does a terrific job with kind of the mathematical optimization formulas that are under the hood, as well as some nice visuals along the way. So this is, if you're in a situation where you're trying to learn about classification in general, like I said, not only do we get the fun intro of this post, but also the appendix is really giving you a lot of great details for how this all really works under the hood.
Absolutely. No, that Battleship. Oh, that's another good one. Where to guess next? That kind of like brings me to the Monty Hall problem a little bit. Like, which door should you pick based on the first door that you selected? I once, I don't know, spent too much time with an actual deck of cards trying to prove out whether the Monty Hall problem and solution was actually the right way to go, and that was probably my first introduction into Bayes without really knowing it.
Isn't it interesting? Hey. It's almost everywhere in your life, but you just may not realize it until someone tells you. Yeah, well, you make me want to play games the rest of the day, but unfortunately I won't be able to do that. But what we can tell you, though, is that the rest of the R Weekly issue has a terrific section of additional resources, tutorials, blog posts, new packages, updated packages, tons more to choose from. So we'll take a couple minutes here to talk about our additional highlights here. And sticking with the earlier part of the show, looking at great uses of ggplot2 for EDA and whatnot, there is a terrific package called ggMagnify. This has been authored by David Hugh Jones, who I believe we have featured on the highlights before, where in essence, you can take a ggplot object and then within that same plot, draw a boundary of, in essence, a panel that you can then use as zooming in on those particular data points and put that in a section on the same plot. This is pretty interesting to me because now, obviously, I'm a big fan of interactive graphics and interactive HTML, where if you had this in, say, Plotly or whatnot, you could just do the zooming of a particular plot in real time, get those coordinates, and then zoom back out. But if you're in the realm where maybe you're confined to static representations, then ggMagnify might be a really interesting way for you to call out a particular section of that scatter plot or that distribution plot, and then be able to really emphasize just kind of what's happening in that sub-region of the plot while maintaining, a good, clever use of space and whatnot. So ggMagnify, never heard of this one before, so I'm going to put that in my visualization bookmarks to follow up with later on.
No, that's a great one, Eric. I'm going to shout out Romain Francois for his blog post on the request perform stream function from the HTTR2 package and how he found a bug and submitted a pull request as well. So he actually asked it, and I don't know, for folks who are connected to him on social media, you may have seen that he has authored a package recently that will write a Valentine's, or not necessarily a Valentine's Day poem, but I think will write a poem for you, I believe leveraging ChatGPT, about anything that you want. I think it started out around Valentine's Day, which is where I saw it first. And he actually ran into an issue asking the chatter package, which is from, I believe, the MLverse, which leverages ChatGPT, which I know a lot of tangential packages have been built on top of at this point. He was asking it to write a poem about Gollum, and he asked it to use many, many emojis in that poem. And unfortunately, he received an error. And one of the reasons for the error, or I think the big reason in particular, is that this package Chatter leverages the HTTR2 package and obviously streams back the response from the ChatGPT API. And it streams it back in chunks of bytes. And unfortunately, it was cutting off an emoji in the middle of the number of bytes within that emoji because it's encoded as a few bytes. And it couldn't essentially stitch together the emoji from two separate chunks of bytes, if you will. So this was, I guess, an unexpected bug, and Romain went as far as submitting a pull request to the HTTR2 package about a way to go about this, potentially, I think, using the read lines function instead of the read bin function. And there's actually, you can go into the pull request. It's linked in the blog post, and you can see, the fantastic conversation, the way that he frames the problem to the RLib team that manages the HTTR2 package. You can see his back and forth conversation with Hadley Wickham on how they eventually went about and resolved and closed this pull request and resolved this bug and merged it back into main. So now if you are installing the HTTR2 package from GitHub and hopefully soon from CRAN, you won't run into the same issue that Romain ran into when trying to ask ChatGPT for a response that includes emojis.
My goodness, yeah, you talk about rabbit holes, right? That credit to Romain and Hadley for finding an elegant fix to this, because this is an area where I take for granted that all these symbols are just going to work no matter if we're passing data in or taking data out. Oh, there's a lot behind those emojis, folks. It ain't just the fun graphics. There are a lot of these raw bytes and bits that if you're not taking it correctly, because we're involving, like you said, the APIs of ChatGPT and this chatter package, knowing what's being handed off, that can be quite important. So, credit to credit to Romaine and Hadley for putting this together. And yes, at the end of the post is a very lovely poem about one of our favorite packages called Golem that will never cease to amaze us.
Absolutely. And I think, it's also, if you do sort of follow that pull request, it's just a great example of how to contribute to a package and to make it easy on the maintainer, or as easy as possible on the maintainers to get that bug fixed.
Excellent. And you know what else makes it easier for you to learn about what's happening in the data science and the R communities? Well, that's where you just bookmark rweekly.org. Have checked that out. Every Monday morning we have a new issue released, like this one we talked about here. But of course, the entire back catalog is also available. You can see right on the home page. And of course, this is a project by the community for the community. It is the lifeblood is you and the community. So we love your pull requests. We love your suggestions. You can get in touch with sharing that resource via pull requests. And we just talked about pull requests, right? Our Weekly is very embedded into that workflow. The link is directly on each issue's front page, where you get a link to the upcoming issue draft for next week. You'll be able to quickly send your pull request there. It's all marked down all the time. Very easy to get up and running quickly. And also, we're always happy if you want to join the team as a curation role. We definitely have spots, and we have links so you can get information on that at rweekly.org. And of course, we love hearing from you in the audience as well. You have a few ways to get in touch with your humble hosts here. One is the contact page. We have the link directly in the episode show notes. We also have a fun little, if you have a modern podcast app like Podverse, Fountaincast-O-Matic, and whatnot, you can send us a fun little boost along the way, which is directly from you to us in your favorite podcast app. And of course, we have some presence on the social medias. I am mostly on Mastodon these days with at our podcast at podcastindex.social, sporadically on the Weapon X thing with at the Rcast, and then also on LinkedIn, sharing some posts and other fun announcements from time to time. And Mike, where can the listeners get a hold of you?
Sure. You can find me on Mastodon as well at Mike_Thomas at fostodon.org, or the other place that I am present on social media a lot is on LinkedIn. If you search Ketchbrook Analytics, KETCHBROOK, you can probably find out what I'm up to.
Awesome stuff. Like we heard about before, congrats on that recent package you open source. I'm sure there are lots of fun stories behind that as well that you'll see on Mike's LinkedIn posts from time to time. So
yes, thank you.
Absolutely. So we're going to close up shop here for episode 153, and we hope to see you back for episode 154 of the R Weekly Highlights podcast next week.